Welcome to Forecast Lab, the Wednesday edition. 8 o'clock here Central Time, and we've got thunderstorms brewing in Texas and in Tennessee, Missouri. Things are really active. So I'm going to go ahead and look at this later, look at Texas in just a bit. Let's check out Tennessee, where we've got reports of a large tornado south of Nashville earlier. That was about 5:53 p.m., I believe. It's from this complex of cells that you see right here. And there's another line further to the northwest along this boundary coming out of Missouri and moving into northeastern Oklahoma as well. What is causing all that? Well, before we delve into those details, let's take a look at that surface map. This is the 7 p.m. analysis about 53 minutes ago. Actually, it's about 1 hour, actually. So, let's take a look at this. We've got this frontal system, a little bit weak, but we don't need a whole lot of dynamics this time of year. That's moving through the Ozarks and into southeastern Oklahoma and into North Texas. The dry line has pulled eastward, dew points running 20 to 40. Junction 45 degrees, 47 there at Del Rio. And I don't know if you can read off the temperature, but there is some heat down there for sure. Let me show you a different map where we can really see that. I'm going to have to go back to my browser. And that's the Western Region Headquarters map, which has a lot of this mesoscale detail. And you can see that temperatures are running up to 103, 105 at Zapata. They had 104 earlier at Laredo, and some hot temperatures up the Rio Grande Valley. So we've had heat in Texas. Go back to that surface analysis, and we'll take a quick look around the rest of the country. One good thing to do is look at the big picture to see what's going on. We see that we've got a surface cyclone there in Missouri, Kansas, Oklahoma, with higher pressure in the northwestern U.S. There it is, a 1034 millibar high off of Washington and Oregon. So that's given us a northerly component coming into the Great Basin area. Temperatures below normal for this time of year. Let's take a look at in the eastern U.S. An outgoing frontal system in New England. Got some of that northerly flow coming back in there with temperatures in the 50s and 60s. But they've had heat as well in Virginia, up to 87 at the Sour at Norfolk. And they saw above 90 degrees earlier today. They were looking for highs up to 87 at Philadelphia, 83 at New York. So that cold spring weather has come to a close. Highs today also reached the 90s in the Washington, D.C. area. The only weather hazards in that part of the country, some coastal flooding in Chesapeake Bay. They refer to that as nuisance flooding. Half a foot of inundation in that area due to high astronomical tides. The most significant effects in the tidal flats and marshes. As we go further to the west, flood watch posted for Kentucky, southern Ohio, all the way down into Tennessee. That's associated with that convective complex coming out of the mid-Mississippi River region. Those flood watches run through tomorrow morning due to that thunderstorm activity. Then as we go south, we get back into that heat once again. If you look at those dew points, there are 70s flowing right up to that warm front. Hot weather, we looked for, I didn't really confirm the highs, but we were forecasting highs of 91 at Raleigh, 95 at Jacksonville, and 92 at Augusta. And we will see another day of 90s tomorrow before this front approaches and moves through the area. Then, of course, as we go to the west into Tennessee, we pick up the more severe convective activity. We had one cyclic supercell early this evening in central Tennessee. Go back to that frame right there. You can see that thunderstorm activity right there. Moving east of Nashville, the tail end of that moving through Murfreesboro, and that's where we had this series of strong supercells over the past couple of hours. So there's our animation. And you can see this other cell on the tail end going over that same area that got hit earlier, and other cells further down through that complex into the southernmost tier counties of Tennessee. Now, as far as that wedge tornado that some of you have heard about, at least it was a violent tornado, it appears. It was in that area right there around Columbia. And I've got a graphic here, Columbia and Spring Hill, what appears to be a very significant tornado. Let me go over to Google Earth there, and that appears to be the track from what I can determine from the radar data. So this is not confirmed. They're not going to be doing the surveys until tomorrow, but you can see that appears to have started maybe east of Columbia near US 412, and this appears to be the center of that track going through this rural suburb, maybe through some forests there, and passing over Interstate 65 right around mile marker 47. And I saw 135 knots of gate-to-gate shear on that storm. Let me show you the footage. Yeah, you can check that out right there. This is from earlier, around 5:50 p.m. Central, showing that supercell crossing that same area. And if we switch over to the velocity, you can see that very tight couplet. That's where we were getting that 135 knots of gate-to-gate shear. That is very typical of the more violent tornadoes. At the extreme, the most extreme events have gone over 200 knots. But this is certainly in the high end of that, and very significant, probably a very significant tornado within that region. I have not watched the chaser footage. I've been busy trying to put this program together, so some of you may know a little bit more than I do about what actually touched down, and that appears to be where that circulation fell apart. So there's the location, well south of Nashville, and there appears to have been other tornadoes in that region. Okay, continuing our survey around the country. I think I've lost my graphic. Oh, there it is. Okay. Yeah, we go back to Texas. There's that dry line. Storms trying to form. We had one storm around Lampasas, out around Temple, Texas, out west of there. That sprung up about 4 o'clock, but could not pull it together. And more recently, we've had other storms around Durant, the Red River Valley, and one of those does have a tornado warning on it. There's what's happening right now, a tornado warning north of Paris. And that's going to be associated with this supercell right there, maybe this other one on the tail end. But let's take a look at the velocities. And unfortunately, Paris is in a very unfortunate area. It's very far from the neighboring radars. You can see Shreveport down to the south, Fort Worth, Oklahoma City, Fort Smith. It's in this box between all these radars, so it's very hard to get good samples. Paris, 14,000 foot where the lowest elevation intersects the storm, and that's not sufficient to capture the tornado. So we're very dependent on spotter reports, media reports, stuff like that for what's actually happening. But we can look at the general appearance of the storm. That's certainly supercellular. And we can try to surmise some of this detail from the velocity, but this is going to be mid-level signatures. We're seeing about 27 in, maybe 45, but there is a lot of beam broadening as those radar beams fan out at long distances. It gets very difficult to capture that small scale detail. So there's a lot of blurring of the higher velocities. You can't pick that up as well. And due to the overshoot up at 14,000 feet, your important circulations are down at 3,000, 4,000, 5,000, or lower if you can get it. We certainly don't have that. So anyway, we've got 27 in and about 50 out. That's about 80 knots of broad scale rotation over a diameter of about 6 miles. So that's a mid-level meso. And the center of that meso is where I put that dot right there. And that's going to correspond to that notch right here. That's where the chasers are going to want to be. But this is not really ideal chase territory. The roads get kind of sparse going north of 84 or whatever that road is. I forgot the name of it. What is it? 82. And of course, Red River, that's a big problem. So people are going to be bottlenecked probably at these crossings right there as the storm moves through. Paris, they have had some significant tornadoes in the past. April of 1982, there was a significant tornado similar to this that tore through the city. And that was kind of a critical storm for further developing the concept of spotter reporting, because the radars were very far from the storm, and that's where it was especially critical to keep up on what was happening. So anyway, that was 42 years ago. Anyway, another thing we can look at is the echo tops. This is almost out of range, but you can see there's tops up here of 52,000, which is pretty significant. And that's about all we have to go with that. And we've got this other cell that doesn't appear to be doing much at the moment, but certainly capable of hail and wind, approaching the western suburbs of Greenville. This is all bedroom community for Dallas all the way up to Greenville. There's a lot of small subdivisions in this area. And this cell probably tracking directly to the east. Let's get a baseline on that. Yeah, it appears it's gone through some cyclic development. You can see that cell right there fall apart, replaced by this other one down to the south. Severe warnings on that cell for ping pong ball-sized hail and 60-mile-an-hour winds. Other weak cells going up in eastern Dallas, probably, I don't know, is there any daylight? Yeah, a little bit of daylight, so probably a spectacular view for some residents around Dallas. And then we go further down the boundary. The storms have tried earlier. There's another puff going up there around San Saba, was that? Yeah, Lampasas, but just not really coming together. But there's significant instability. The dew points, let me show you that. For that, we're going to have to go back to the browser, go back to, see if I can get this to come up, aviationweathercenter.gov. That's a good place to go. I don't know if any of you use this site. I definitely recommend it. It's not just for pilots, because they've got a lot of good content on here. And you're going to get a map that looks like this. And that's certainly useful for weather analysis. Why is this in Celsius? I don't think I've ever had that happen before. That's very strange. How do we get that convert over to, let's see, U.S. customary? I wonder what's going on there. Anyway, I was going to show you the dew points. I'm going to go to that other website because we can see some of that going on here. Dew points are running 75 to 77 degrees through a corridor between Houston and Dallas, coming up from College Station and coming up from the Gulf. Those are high even for summertime standards. And I'm not really looking so much at, cooperative, whatever you call it, amateur weather data, because, those sensors can be in error. But where we can pick up the federal stations, like Tyler right here, this is a federal station at the airport, they're reporting 75, so that's good data. When the data comes up, yeah, Palestine, this is the airport reporting 77 degree dew points, so this is some sultry air. And that really kicks up those theta E's way up and pushes those skew-t parcels over to the right. And that's what gives you that high cape to get these strong storms going. But unfortunately, well, fortunately, you know, I don't want a big tornado outbreak in Texas. We do have what appears to be a strong cap. Let's take a look at that. For that, we're going to go to the high-resolution radar data. So I'm going to go over to pivotal weather and let you check out some of this. So we focus on Texas for a moment. And we zoom in on the state. And so if you're pivotal weather, you get your map to come up. A good chart to start with is going to be the theta E right here on the left. Because where the theta E's are higher, that's where your parcels are going to be further over to the right on that skew-t diagram. So this clearly shows us the theta E ridge coming up from Victoria, College Station, and on up towards Longview and Tyler. So we can just grab this sample right here over Dallas for maybe an hour ago, and you can see that sounding right there. So the dew point line way over to the right, the temperature line way over to the right, and we've got this very steep lapse rate from the surface on up to 39,000 feet, and that's going to be the stratosphere. The wind profile, it looks a little bit straight line, and that's why I think we're not seeing a big outbreak of tornadoes here. See the problem right here on this sounding? We need to actually pull out a few more soundings and check the integrity of that data. Yeah, see right here, yeah, there's actually a little bit more curvature right there. That's not substantial. That's not like what we saw in Oklahoma the other day, but still enough to sweep out some SRH right there. That's going to correspond to maybe 100 to 200 SRH, yeah. So that's the way that looks. And when you use this product, you're going to want to look at a few other areas and just kind of poke around and look for consistency. See, like right here, there's a little bit of veering aloft up at 2 kilometers, which takes away from the SRH here. Yeah, there's even more. It looks like there's kind of a push of northwesterly flow aloft, maybe more westerly in the mid-levels, and kind of pushing that hodograph around. Okay, so you can check that out on your own. I thought I saw a cap there. Yeah, a little cap right there. That's probably what's helping to suppress a lot of this thunderstorm activity. So there's Hillsboro, a little bit of capping. And the other factor is the moisture decreases as you go off the surface. But yeah, the satellite imagery has been pretty impressive this afternoon. Let me go back to Texas, and then we'll finish up there. I know not everybody is in Texas. Other things going on, but right there at the very end, if I can pause that. Yeah, you see all that dirty air mass right there? That's all reflection from haze. Visibility is down to 2 to 3 miles in East Texas. Why is that haze there? Well, we've got very high relative humidity. When you have high relative humidity and enough aerosols, you don't have to reach saturation to get clouds forming. You can get clouds forming like a thin mist, even when the RH is down to 90 or 85%. And that's what's happening there. So there's that soup right there. And then as you go further to the west, we get into dry air out there in northwest and west Texas. Anyway, yeah, those anvils going up around Paris. And you can see the satellite switching over to infrared right there at the end, since there's no daylight available at night. And if there is, then we've got even bigger problems. Okay, let me just check real quick on comments. We've got some viewers here. And it's kind of a small webcast because, you know, we are more technical here and we don't go over, you know, all the very basic stuff. We don't use a lot of fancy graphics here. We focus on the information and the data. So It's probably a little bit more cerebral, a lot of technical stuff to go over. And if I lose you, just let me know, and we'll try to tone it down a little bit. But anyway, I've got Christopher Kane here checking out on chat. Rob Strecker, ESCH Daddy. Yeah, thank you for the comment there. King of Met, Rob Lucero. Thank you very much. And Stormy Steve. Thank you all for joining us. And let's take a look elsewhere around the country. I'm going to do something a little bit different, just head out to the southwest and kind of work our way to the east. And it looks like they've probably got a little bit of forest fire activity there in Arizona. Right there around Flagstaff, maybe towards Winslow, in between there, along Interstate 40, something going on there. But you can see that strong westerly flow right there coming in through the southwest, helping to drive that zone of strong pressure falls there in the panhandles and further out east. And then as you go further north, we pick up some of the strong cold air advection. You can see some showers there in the mountains of the Central Rockies. And they are looking for a cold night tonight. Farmington, located right here in New Mexico, they're under a freeze warning tonight. Temperatures down to 29 degrees. And we are looking for some cold weather in Utah and Nevada as well, as that cold air filters southward. Had that on my notes, but I think I lost it. Anyway, let's head further up north and check out the northwestern U.S. And this is where we're getting into some of that troughing, some of the northerly flow back in behind. You can see the gyration, the rotation of the upper level winds right there over Nebraska and South Dakota. There's an upper level low located right here. That's partially responsible for the steep lapse rates and destabilization, the strong winds across the southern and central plains. So let me take you to the upper level graphics and we'll see what's going on there. So we'll go to the slideshow here, and I'm going to show you the 500 millibar chart. I actually designed these based on the daily weather map. I don't know how many of you remember the old daily weather maps that used to come out of the Weather Prediction Center. They've changed a lot in the last 20 years, but this is the classic design. So if you go back to those old charts from 40, 50 years ago, you're going to see them appearing like this. This is actually showing a blocking pattern through the central U.S. We've got one stream up there into British Columbia, into Ontario, another stream across the southwestern U.S. into the southeast. And this is a very persistent blocking pattern. It's going to stick with us for probably a good week. You can see how the flow changes very little going into Friday and Saturday. This upper level low just kind of wanders into the Four Corners area. The southern U.S. remains under strong westerly flow. And as this trough lifts out on Sunday and Monday, storm chances probably going back up, because that upper level low is co-located with colder conditions aloft, which increases the lapse rates. And there's some retrogression of the long wave trough going into next week. And we end up with this long wave right here in the central U.S., which is favorable to smaller scale troughing, and also it tends to be linked with cooler air in the lower levels, so probably that will take a bite out of these hot conditions in parts of the central U.S. Then going into the end of next week, that troughing persists. So as long as we have that troughing moisture flowing north, there's going to be chances for severe weather on the Great Plains. So I think we're looking at kind of an extended period of severe weather. Maybe not every day, but there's certainly going to be a lot of activity. And you can see the distinct lack of ridging. The ridging tends to shut things down in May. And we can zoom out just a little bit further and look at the continental pattern, if I can find it here. Yeah, there's the jet stream level winds, 250 millibars, showing that cutoff low in the central U.S. And then as we go into the weekend, not much change, just a continuation of that split flow pattern. The southern stream continues to be active, and any severe weather will tend to concentrate a little bit more heavily along these jets. You don't really 100% need the jet, but it definitely helps organize the storm and gives us longer lasting structures. So here, Thursday next week, this could be a period of severe weather in the central U.S., troughing, strong upper level flow, 110 knot winds. Somebody's going to get beat up with severe weather. And then we get to our last frame for Saturday, May 18th. That's what it looks like. And the flow remains pretty feisty there across Texas, 55 knots, which will support storms wherever we can get a boundary and ample low-level moisture, assuming we're not capped. All right, before we get back into what's going on right now, I'll take you through the forecast sequence. There's our series of fronts this evening with the dry line extending south. Then as we go forward into tomorrow, this cold front sinks south into Oklahoma, Arkansas, and Texas. We're looking at cooling for the northeastern U.S. right up in here. 50s and 60s filtering south into New York and New England. Continued scorching weather in parts of Texas. We're going to see 108 at Laredo, right there in that region, the lower Rio Grande Valley. We're going to see 106 at Del Rio, 94 at San Antonio, but it will cool off, getting tongue-tied here, 80s in North Texas and 70s in the Panhandle. See that northeasterly flow right there? And that's actually going to develop canyon winds in the Sangre de Cristos and west or east of Albuquerque. So Albuquerque is under a high wind watch for tomorrow night into Friday. Those winds could be gusting out of the northeast up to 60 miles an hour. Vast amounts of precipitable water across Texas, 1.5 to 2 inch right there. So we're looking for maybe another round of severe weather developing somewhere between Dallas and Austin, and that'll propagate rapidly through the night into Alabama and Georgia. So we're probably looking at another severe weather evening for tomorrow night. Then going into Friday, let's carry this forward. You're going to see that area of thunderstorms pop up right there. And during the night, 1 in the morning, moving into Mississippi, and then into Georgia at 7 a.m. So rapid movement eastward. And there comes that cold air flowing into Texas. Moisture continues to hang around in the southeast Gulf Coast region on Friday. Precipitable waters will remain in the 98th percentile across parts of Georgia, but most of the storm activity will be confined Friday afternoon to the coastal regions and around Jacksonville and the Florida Panhandle. Massive warm-up in the northwestern U.S., Oregon, Washington. Friday, they're going to be hitting 90 degrees at Portland, 80 degrees at Seattle. So it is going to be a warm weekend coming up. Then going into Saturday, cold air advection to the Gulf Coast, the Great Lakes region right there. You can see that northwesterly flow through Chicago, Milwaukee, and Minnesota. An increase in thunderstorm activity and clouds in Texas. This is a kind of a cold season wintertime overrunning pattern. See that right there? At the surface, the winds are out of the east and northeast, but up at 850 millibars, 5,000 feet, they're coming out of the southeast. That's that overrunning. That's bringing up that tropical moisture up and over this ridging. Overrunning is another name for isentropic lift. The air that's flowing northwestward has to ascend to conserve its potential temperature. And as a result, we get saturation, we get clouds, stratus, stratocumulus, nimbostratus, all that stuff. And if it's unstable enough, we'll get cumulonimbus as well. So that's what's going on there, and that's a response to pressure falls out to the west. And as we go through the evening on Saturday, an expansion of that precip, that moisture returns up the Rio Grande Valley's precipitable waters in the 98th percentile, 1.5 to 2 inch precipitable water in the south half of Texas. It's like an unwanted guest you just can't get rid of. You know, we're dealing with it today. I've got a dehumidifier running in the other room. I think our AC may be iced up a little bit because, you know, when we get that severe humidity, it is hard on the AC systems. It's very hard to keep that moisture from freezing on the coils. Then as we go into Sunday, it's going to get even worse with that moisture. We're looking for 2 to 2.5 inch possible across Texas. No, I'm sorry, 1.5 to 2. I'm getting that confused. It's still going to be pretty high. You can see all this precip building across Texas, and then gradually shifting to the east as we go into Monday. Probably another overnight MCS sometime Monday or Tuesday, and maybe some severe weather. You can see the southeasterly winds, the synoptically driven weather regime, that warm front. This is all going to be concerning for severe weather. Maybe Monday night. I think by Tuesday night it should be all to the east. Maybe parts of the Carolinas will be experiencing some of that. Okay, let's take it through the remainder of the sequence. Severe weather possibly building for Wednesday and Thursday. You can see the dry line is back. Looks like it's going to be active in Kansas and Oklahoma. The wave shifting eastward. Overnight Wednesday into Thursday, cold front coming south, and then thunderstorm activity down to the south Thursday. We clear that out, and there comes another front for Saturday, May 18th. So we're getting closer and closer to summer here. It's hard to believe that, you know, pretty soon we're going to see those temperatures up near 100, probably just a matter of 5 or 6 weeks here in this part of Texas. And I'm hoping the West Coast escapes some of that heat. I still remember what happened in Portland a few years ago, that 120-degree temperatures. That was crazy stuff. All right, let's go back to that severe weather since we try to cover everything. Numerous tornado warnings at this time as those supercells progress into eastern Tennessee. Yeah, it's quite a number of those. I've frozen that on the latest frame. Looks like we've got 1, 2, 3, 4, 5, 6 tornado warnings and another around Decatur and Huntsville. Look at that. It's just crazy. I'm going to try to pull up the Huntsville radar real quick before we move on. So it's going to take a couple minutes to come up. In the meantime, we can look at the Texas situation. That little speck around Lampasas didn't do anything. We've got that other cell in Greenville. It's moving to the right, taking a southeast track towards Emory and Lake Tawakoni. I'm not sure how to spell that, but yeah, there's a little lake right there. So that's continuing to drift southeast. This cell right here over Dallas, not really doing much at this time. Let's take a look at the echotops. It is, yeah, it's up to 42,000. It's definitely trying. When you're looking at these young cells, you need to look at all the tilts because often there's a lot of stuff going on aloft. You can see we're picking up higher reflectivities as we go up to 6,000 feet. We go up higher into the storm. There's 12,000 feet. This is sitting right over East Dallas, Buckner Boulevard, 635 East, Mesquite, Forney Road, that entire area there. And we go up higher in the storm. Yeah, we just had a frame come in there. Yeah, we're actually getting about 54 dBZs up there at 23,000 feet. And it's dumping quite a bit of precipitation off to the east there. So, yeah, that's that cell. It is trying, and it may very well organized. And if it does, I would expect it maybe to take a track kind of like this. Kaufman, Terrell. If you're in that area, you'd probably want to keep an eye on the statements and warnings and watches. Okay, so there we've got our storm going through Greenville. We just talked about that. Still got a tornado warning on the storm east of Paris. One final look at the velocity. Again, this is way up in the mid-levels of the storm. We're getting about, this is up at 18,000 feet. We're getting about 24 in and about 60 out. But, you know, again, beam broadening makes it really hard to make conclusions from this data. But that's going to be the centroid up at 18,000 feet, and that's going to be in that notch right there. And I think about this time you're going to want to start using the Shreveport radar. I don't know which one's closer. Fort Worth, 129. 103 for Shreveport. Yeah, you're going to want to use Shreveport for this storm. Other cells further up the line, up in the mountains southwest of Fort Smith. And let's go back to Huntsville. There's where we have our numerous tornado warnings. We zoom in on the Decatur-Athens storm. And it is quite a mess with all those tornado warnings. Pull them off so we can actually see something. So this is going to be east of or west of Athens. If we look at the velocity, these are not terribly high velocities, looking at 23 out and 35 in. So that's going to be about 60 knots of shear. It is kind of wide, looking at about 2 miles diameter. So this is probably a rotating wall cloud. I don't know what's at the surface. Maybe you guys are seeing something different on the other channels, but I don't really have time to look at all that. I mean, there could very well be something on the ground, but just looking strictly at radar indications, this does not look particularly interesting at this moment. Let's see how far we are from the radar. We are 48 miles. So that is going to cause a little bit of sampling error. This is just now starting to come within range of tornado detection. And we go up to the higher tilts, look for consistency, and it's very similar. And then we look for time consistency. We go back and forth. And yeah, it looks like there was definitely something there earlier. Yeah, stepping back right there, that's 45 in and 10 out. And it looked even more interesting earlier. This is 22 after. This is about 15 minutes ago. That looked pretty strong right there, especially at that range. 23 out and 47 in. So I'll take you through the reflectivity. Yeah, definitely a well-developed hook right there. There's the updraft region. There's the forward flank downdraft, rear flank downdraft right there, and the hook. So the air is kind of doing something like that right there. So this is the place to be if you're Reed Timmer in that chase mobile trying to get good footage. And you can see that concavity starts to fill in a little bit as we get up to the current time, and maybe starting to show a notch again as it drifts towards Athens. Okay, so that is the lowdown on that stuff. What is this going to do overnight? We can take a quick look with a high resolution rapid refresh. If you're wondering what this is going to do later as the evening goes on, this is a good strategy to use. And we're going to go to the southeastern U.S. Trying to figure out if we have a frame that covers that region. Yeah, I guess, yeah, that's a good one. We'll use that one right there. We switch over to the reflectivity. That's 0Z, high resolution rapid refresh data. And you can see that convective cluster there. It appears to be modeled fairly well, not capturing the stuff in Alabama all that well, but you know, we can look at the general trend moving into the Blue Ridge Mountains. Trying to move this so you guys can see a little bit better. So this is going to be valid at this time up at the top. Run that back. Yeah, there you go. So this first line moving through the Blue Ridge Mountains, according to the model, about midnight to 1 in the morning. And then a second line right here, a large outflow-driven complex moving into Tennessee through that same storm-ravaged area around Nashville and moving into Georgia for around dawn. So it's going to be a busy night for these forecast offices in this part of the country. And if you are not really all that familiar with the weather, you're going to want to keep in touch with those National Weather Service statements to see what's going on. Okay, how long have we been at this? Let's see here. 43 minutes. My God. Okay. I think that's probably a good place to stop. I hope you all learned something. And we're just kind of experimenting with these live casts. I don't know if we're going to continue to do them. We do get a little bit more, there is a little bit more quality when we pre-record these, but it is not good for keeping track of stuff like this. You know, I don't want to be showing you 4-hour-old data when stuff like this is going on, so it's better for me to do this live. So I'm going to probably try to do this when we have severe weather going on. Yeah, this looks pretty bad right there. What is that, Manchester, Tennessee? These definitely all look supercellular. So we'll see how things go. You can provide feedback, leave comments, what you think about these live casts, whether you prefer the old recorded versions, and weigh in on that and let me know. Okay. I think that'll do it for this edition of Forecast Lab. Again, I hope you enjoyed it. Remember, you can support us on Patreon. That link will be coming up shortly. Or you can pick up a forecasting book at weathergraphics.com. So certainly consider that. Hope you all have a great evening. Take care, and we'll see you back here on Friday. Bye-bye.